Welcome to the channel. In this problem, we have to find out the magnitude of the gain at frequency 16 kHz. This is simply frequency dependent inverting amplifier. The input is applied to the inverting terminal, where positive means non-inverting terminal is connected to ground. Without capacitor, this is simply like an inverter. But with capacitor, we need to consider the frequency dependent operation of this operational amplifier. Because of this capacitor, this is like a frequency dependent inverting amplifier. So taking the values of the component, Cn is given, which is equal to 10 nanofarad. Then our input is given, this is input resistor, which is 20 kilo ohm. What is next given? RF, that is feedback resistor, 200 kilo ohm, and feedback capacitor is also given, that is 100 picofarad. First of all, in this case, we have to find out the reactance of the capacitor at the input terminal and in the feedback terminal. So I consider reactance of the input capacitor Z10. This is equal to, the formula is like J omega C in, which is nothing but 1 upon J 2 pi F C in, and which is equal to, here the frequency is given. I write the frequency here. This is 16 kilohertz. Frequency is given 16 kilohertz. Input capacitor value is 100 nanofarad, and from this we can find out the value simply negative minus say 6.25 kilo ohm. So value of Z is minus 6.25 kilo ohm. So this is the reactance of input capacitor. Same way, and in the same formula, we are taking the reactance of the feedback capacitor. So this is simply saying 2 pi F CF. We know the frequency is 16 kilohertz and feedback capacitor is 100 picofarad is given. So what I'm getting, this is minus J 62.5 kilo ohm. So first of all, we found the reactance of input capacitor, reactance of feedback capacitor. We know that the gain of the inverting amplifier is the ratio of feedback resistor divided by the input resistor. So I consider the feedback reactance first. Say Y2, this is equal to the parallel combination of feedback resistor and feedback reactance. So I'm taking parallel combination RF into ZF divided by RF plus ZF. So we calculated the value of ZF, which is minus J 62.5 K, and the RF is given, that is 200 kilo ohm. From this we can find out the value of Y2, and what I am getting, that is 55.17 minus J 43.1. So this is the value of Y2. Same way we can find out the value of Y1, and which is equal to the series combination of resistor and capacitor reactance Zin. So this is Rin plus Zin, and what we are getting in this case, 20 minus J 6.25. So Zin we know minus J 6.25 kilo ohm, and input resistor is 20 kilo ohm. By putting these values, we are getting Y1 20 minus J 6.25. Now the gain is, this is inverting amplifier, so gain is negative Y2 upon Y1. But what they asked, we have to find out the magnitude of gain. So take mod of A, which is equal to mod of feedback resistance divided by input resistance. So this is mod of feedback resistance divided by input resistance. So total feedback resistance is Y2 and total input resistance is Y1. So which is equal to, what I am getting, So putting the value of 55.17 minus J 43.1 divided by 20 minus J 6.25. So after solving, putting the values of y2 and y1 and taking the magnitude of this, we are getting the gain of magnitude. What we are getting? 4.45, and which is approximately equal to 3.5. So we can consider option 4 is the answer of this question. Magnitude of gain, which is 3.5 approximately. So 4 is the option of this question. So this is the solution of this problem. Thank you.